So like I said, we're using the same function, We're finding a symmetric difference quotient. It's centered around 1 because that's the derivative that we're trying to approximate. All right, and so I just wanted you to, all right, center it around 1 with a 0.001 in each direction. And again, you're plugging these values right into your calculator to y, like you're using y1, that should still be there. Okay, what did you guys get? 30.685, blah, 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 right? Okay, but if we round it, 30.685. Okay, now what I want to show you is that there is actually a feature on your calculator that will take the derivative without having to use a difference quotient. Okay? All right, so let me pull up my calculator here. All right, now your function absolutely still needs to be in y1. Okay? All right, and so what you're going to do, all right, is you're going to press the math button. You're going to press the math button. Everybody know where that is? It's under the alpha button. And then if you scroll down, because some of you can see more on a screen at one time, if you scroll down to number 8, it should say in deriv. Yeah? All right, select it, please. Nope, hit the wrong thing. Math 8. All right, and you should get this weird notation. Math, so just say clear. All right, math 8. Or scroll down to 8. All right, so do you guys remember watching the videos that one of the notation was like dy over dx? Yeah. Okay, that was one of the notations they talked about in the videos, and that just means the derivative of y with respect to x. Okay, so that's kind of where the notation on the calculator comes in. They want you to put an x in that first box, because you're going to be taking the derivative with respect to x. But instead of putting a dy on top, in the next parenthesis, that's where you're going to put the function that you want to take the derivative of. Well, where is that function stored? In y1. So how do I just plug y1 in right there? Alpha trace. Ah, oh no, I am recording. I was like, I forgot to hit record again, but no, it's good. Okay. And then we choose y1. Now, the calculator, and we will learn soon how to actually take the derivative without a point. The calculator can only do it with a point. What point do you think I want to plug in for x? 1. And hit enter.
What you put in the first box?
X.
Oh, you just literally put it in X.
Yeah, because you have to tell it that you're taking in the derivative with respect to x. X is your variable. Then you put y1, that's your function. And then you put x equals 1, because that's the number you want the calculator to plug into the derivative. All right, look what you got. Whoop, d prime of 1 was what? 30.685, yes? Okay, so the difference quotient gave me 30.685 because I was very, very close to 1. And then the actual derivative on the calculator also came out to be 30.685. Okay? All right, well, now that we know how to use the calculator, I want us to find the derivative d prime of 2. Okay? Now, do you think you could shortcut it on your calculator? What could you do? Second enter, and then arrow to the 1 and change it to a 2. Okay? Ah! Did y'all hear Will at home? He said the door is closing. Where on earth did he get that idea from? The rate is now negative. Remember, this is a rate of change. All right? And so I do want you to make that connection in your notes. Okay? So on your paper, all right? Again, you can pull this up later. All right? D prime of 2, you need to record the answer was negative 19.315 if we round. Okay? And again, what do the signs tell you about the motion of the door? Positive. Door opening, right? And so you guys just noticed that when it was negative, the door was closing.
So what is it when the door is just like a standstill?
Well, let's figure that out. Okay? All right, before we move on, I want to go back up here to the graph. Come on. Here's my graph. Here's time 1. Here's time 2. All right, if I go up to the graph, all right, what do you notice about the graph when we said the door was opening at time 1? What's happening on the graph as we go?
As you pass 1.
As we pass 1, what's happening on the graph? All right, I'm even more generic than that.
It's the instant it is reaching up.
It's reaching the top, it's going up. All right? What's it doing what's the graph doing when we said the door was closing? It's decreasing. Okay? So there's a major connection there. When the derivative is positive, the graph is of f, the original, is increasing. Please write that down.
Wait, one more time.
When the derivative, and I'm just going to say f prime of c, like that's the derivative. Actually, let's make it the whole function. Let's just do f of x. F prime of x is positive. The original graph, f of x, is increasing. When the derivative is negative, f of x is decreasing. Now, I know that we're not going to be using Desmos to find things in here, but I want to use Desmos real quick to show you something very interesting, because the graph, I can make the graph really big up here. All right, if I type in the original graph, all right, that we had f of x equals 200x times 2 raised to the negative x. Whoa. All right, I do have to change my window. Remember, we did all this before on our calculator. Okay, so all right, so that should look like the one we did on our calculator. Are you guys okay with that? Where's my mouse? I want you to go away. Okay. All right. So now I'm going to graph the derivative. Okay. On your calculator, all right, I want to show you how to graph the derivative. Go to y equals. Do not get rid of what's in y1, because you're going to tell it to take the derivative of what's in y1 and graph it. Okay? So go down to y2. All right, where do you get the derivative in your calculator again? Math 8. All right, what do we have to put in that box? X. What do you think is going to go in parentheses? Y1. Alpha, trace, enter. Okay, now I want the calculator to really take the derivative at every point and graph it. So all I'm going to put here is another x. Now this is the only thing the calculator can do in terms of derivative of the whole thing is to graph it. Okay? Now if I hit graph,
why does yours show up and mine doesn't? How big is our window?
well, we had our window before.
I think it was the bathroom.
Oh, okay. But did you guys notice that you can't see the whole thing?
Mm-hmm.
All right, so I'm gonna have to change my window again. I need some more values in the minimum in the y's. Let's see if negative 25 is enough. Whoops. Oh, because I put it in the wrong spot.
Negative 25 is not enough. Oh, I wasn't looking
No, let's see. Oh, not quite. Not quite. All right, so how about negative 50, negative 35? I don't know.
Either way. 200x times 2.
All right, now I really like my calculator up here because it's colored, right? How do I make this bigger? Nope, that's not the one. Oh, here we go. Here we go. There's nice and big now. All right, so maybe I don't need Desmos. Maybe I don't need Desmos. All right, so I had to change my window to fit it. Are we okay with that?
One for y max.
Y max is 135.
135.
I'll put a negative what? So 135.
I'm zooming in a little bit more. There we go.
It's like 135.
Okay. So, all right, so what I want us to see is what we just wrote down, and I don't think it won't let me write on top of it. And if even if I have a tool that I can write on top of it, but you guys at home can't see it. Okay, so what we just said was that when the derivative, which on my screen is which graph?
The one that's upside down.
All right, the red one, right? On my screen, it's the red one. Okay, when the derivative was positive, all right, I want to write on it, but you guys at home can't see it if I write on it. Okay, so I'm talking about the red graph being above the x-axis.
Mm-hmm.
Yes?
Mm-hmm.
Okay, that's when the blue graph is increasing. Okay? So where the red graph is above the x-axis, it's positive. The blue graph is increasing. You with me? And where the red graph is below the x-axis, the blue graph is decreasing. Well, what's happening when like on the red graph, what happens when you change from positive to negative? No, on the red graph, what happens when you go from positive to negative?
0.
You're at 0, right? What's happening on the blue graph when when the red graph is equal to 0?
It's at 0.
No, the blue graph.
Oh, the blue graph is at 1. Or it's at the point where it stops and it's about to start going down.
Okay, what do we call that hill on the graph?
Equal to this. Vertex.
Well, it's not a true parabola. It's only a vertex on.
The turning
What's
point?
another name? Yeah, what's another name for the turning point if it's at the top of a hill?
Oh,
What's another name for a turning point at the top of a hill?
Kinetic.
A math word.
There's no take. Don't say it.
Convex.
Okay.
Maybe.
P.
Turning point.
Say it again. Maximum. Okay, if we're at the top of the hill, we're peaking. Okay, and we're changing from increasing to decreasing. We have a maximum. Yes. Okay. So that's another thing I want you to make a connection with. So let's go back to our list here. All right. When the derivative equals 0, that's where the red graph crossed the x-axis. That's where it went from positive to negative. Okay? What happened on F? What happened on the blue graph? Well, R specifically had a maximum, but in general, okay, we have to add some things here. When f prime of x equals 0 and changes sign, that's important. All right, because can't you equal 0 but then go back into the positives? Okay, so it does have to change sign. F of x has a relative, we're going to use real math words here, extrema. Extrema is the plural word for a max or a min. Okay? Now, there's a specific time when it's a max, and there's a specific time when it's a minimum. Okay? All right, so let me make sure I say it right. Okay. Okay, so when f prime of x equals 0, and changes sign from positive to negative, specifically. It has to be in the positives first, then in the negatives. Okay? Let's put a whole lot of stuff together. F of x would change from increasing to decreasing. Well, if you go up and then you go down, what's at the top? A maximum, right? So, f of x would have a maximum. And we're going to be more specific, would have a relative maximum. And of course, you could say max for short. So when do you think you'd have a minimum?
When it's changing from negative to positive.
Good. Okay. And you have to be careful about using the word it in calculus now, because if you're talking about a derivative function and an original function and you say it, especially on the AP exam, they won't give you credit for it because they don't know what you're talking about. Okay? And so I just wanted to point that out early. All right? So we're going to say when f prime of x equals 0, so that's when the derivative of the function equals 0, and changes sign from negative to positive, all right, what's happening on f? good. F of x would change from decreasing to increasing. So f of x would have a relative minimum. Cannot spell today. Minimum. All right, that is a huge, huge calculus concept. Okay, huge. Got that covered. That covered. All right. Where's my okay. I know. Okay, so I don't think we have enough time to go into all the other details I want to talk about today. So we're gonna stop there.